Pillar 2. Manufacturing process reliability. Operating procedures. This subject area relates maintenance and reliability activities to the manufacturing or production process of the organization, to ensure that maintenance and reliability activities improve the manufacturing or production process. This subject requires an understanding of applicable processes, document process flow, process parameters, quality specifications, process risk, and operating procedures. A complete understanding of processes that influence the performance and safety across all disciplines, and at all levels of the organization can provide tremendous benefit. The ability to react appropriately to changing conditions in the process allows for real-time process control and optimization. This ability to react to change applies not only to one's direct function but also to its effects on the total process. Process understanding includes how to start up, operate, shut down, analyze, and troubleshoot. And it also includes methods for communicating and documenting continuous improvement activities in operations, maintenance, quality, and safety. Clearly defined the standard operating procedures and flow diagrams of processes are helpful tools in communicating and documenting the desired process performance. Plan and evaluate the process. When developing or revising a new process, care should be taken to develop a list of things that could go wrong. When evaluating a current process, analysis of the process is limited to the current condition, initial design attributes, and flaws. Periodic evaluation of all processes is a best practice. Several factors can change the effectiveness of a process over time. Each process evaluation must include perceptions, favorable and unfavorable, and interviews from each department, or group that supports, or interacts with the process. The perceptions voiced via the interviews point to deficiencies in the process. Documenting process deficiencies will ensure a clear understanding of opportunities for improvement. A documented risk identification procedure should be developed and implemented, and then used to assess process-related risk. In turn, this procedure will lead to the development of necessary control measures, and modification of the process with risk mitigation measures. Adopt a process monitoring practice. Regardless of which process monitoring program is adopted, the best way to ensure its success is to elicit participation from each department, or group involved in, or affected by its execution. If process monitoring programs are already in place, then evaluate the effectiveness of those programs. If the programs are not meeting organizational goals or objectives, make adjustments to improve. Historical process information, including successes and failures, should be taken into account in the development of a manufacturing process. Process selection and development requires careful consideration. Avoid developing processes that will require immediate or frequent changes. Constantly changing processes is detrimental to the overall success of the program. Maintain consistent data collection. Consistently accurate and timely data collection is the most difficult challenge facing reliability programs. Incorrect or missing data can cause poor decision-making that leads to errant program direction. Data collection must be based on documented data standards. These data standards should follow industry standards where applicable in order to enable benchmarking across industry. Accuracy should be emphasized over quantity. Data control should be ingrained in the culture at facilities with any kind of reliability program, and it should be supported at all levels of an organization. Data accuracy should never be the responsibility of one person. Everyone that interacts with the process should provide clear, complete, and accurate data in the proper format. Data analysis. Analysis of the collected data is necessary to maintain effective processes. Raw data collection is of no use without analysis to discover opportunities for improvement. Several methods for analyzing data are available in the industrial sphere. Determine which method of data analysis would best promote the organizational goals. Process flow chart. Much can be accomplished by a process flow chart, simply defined as a visual representation of the steps in a process. Synonyms are process mapping and flow diagrams. The construction of a process flow chart should be one of the first activities of process improvement. Process flow charting offers several benefits for the organization. It helps end users understand the process. It helps identify waste in the operation as well as bottlenecks. Since process flow charting is a group effort, it promotes teamwork and communication while keeping contributors on the same page. Constructing a process flow chart based upon the steps of a process is an easy and efficient way to understand the process. The chart should be used early on in any process improvement activity. Benefits are identifying wasted steps and highlighting bottlenecks. It also has uses for training. When constructing process flow charts, all departments affected by the process should contribute to ensure all steps are covered accurately. Statistical process control. Statistical process control is used primarily as a quality control tool. SPC uses statistical methods to understand process parameters. Software programs provide effective process data point measuring and monitoring as well as data interpretation and, ultimately, process control. A process that is in control will yield the greatest benefit by eliminating errors, minimizing waste, and increasing throughput and predicted consistency of the process. Understanding process parameters. A process variable should be measured and monitored constantly to determine if the process is operating within the control band defined by the OEM. Process variables can be temperature, pressure, flow, pH, density, turbidity, chemical composition, and so on. Processes are optimized by operating process variables at a set point and regulating the proper functioning of process elements and operations. Process parameters are an essential part of process management, and extremely important in controlling a process. Therefore, process parameters need to be continuously and accurately measured and monitored throughout a process run. Process parameters maintain the process efficiency, and may be controlled with the help of technological sensors mounted at critical areas of a process, along with implementation of special methods and equipment to adjust them. If a parameter deviates from its set point, goes beyond the acceptable level of variance, the root cause can be due to an automated process controller failure, or possibly an equipment failure. To restore the process to a controlled state, operator intervention is recommended. The operator should evaluate the process, determine what caused the process to deviate outside of the control band. He should then take appropriate action to override failed automated controls, and stabilize the process to prevent further upset, and also he should notify appropriate personnel. Understanding risk. The understanding of risk requires the classification of processes and their scope. The subject matter expert, SME, team should be able to identify credible risks, and subsequently the current risk controls. They would also be able to determine level of risk, and therefore the tolerability of risk. Risks are categorized according to their dominant, controlling areas, which are those areas that would be most affected if it materializes. Knowing these 6 areas will influence the means to mitigate known risks. The 6 controlling risk categories are safety, environmental, financial, operations, property, and reputation. Known process risks can be approached in several ways. Budget for risk if there is no feasible mitigation strategy available. Cease activity which incurs the risk. Treat the risk with inspections, modified operating procedures, or spare parts accessibility. Or transfer the risk by means to a third party, for example, an insurance policy. Processes. Quality management system. Each empowered team must define its manufacturing process and requirements for specific production outputs. Manufacturing processes should be as simple as possible. Critically evaluate processes at set intervals. Remove unnecessary process hurdles, consolidate process steps if possible, and minimize the number of process touchpoints. Focus on what the process is trying to achieve with the overall corporate end goal in mind. To get buy-in from every stakeholder affected by the manufacturing process, document the entire process, and have each person review, approve, and understand each step. This approach will establish expectations. It will be easier to refer to an archived meeting training document rather than to remember verbal details from a meeting training session. Ensuring that the manufacturing process is understood by all operators and supervisors is the key to achieving high-quality results. Once the manufacturing process is documented, and expectations are set, and all stakeholders agree upon and understand its content, then one can write a clear and detailed, standard operating procedures for the process. Formulate operator and maintenance training that clearly and completely defines how to operate and maintain the process equipment, and how to keep it operating at peak performance. Hold manufacturing process owners accountable through goals and periodic, consistent review of KPIs. The owner of the manufacturing process will be highly motivated to ensure success if they are being graded, and ultimately compensated, based on the success of their work. Develop an in-house work management process self-assessment tool, or adopt an existing tool, and use it to periodically to evaluate applicable quality standards, to look for changes, and to identify opportunities for improvement. Understanding and acting appropriately on trends allows organizations to stay ahead of below-the-surface issues with the manufacturing process. This focus on trends allows the manufacturing process to be optimized, and provides input for continuous improvement, leading to actionable tasks. ISO 9000. 9000 is the foundation for making high quality become second nature. The three fundamental aspects for establishing a high-quality culture are implementing verifiable quality controls, documenting the various operational processes and procedures, and ensuring that the appropriate quality emphasis is established and followed by everyone in the organization. ISO 9000 series of standards enables product and service suppliers to assure prospective and current customers that an operational quality system has been established. This concept of a two-party contractual relationship is inherent in the ISO 9000 standards. The series offers the most fundamental and basic aspects of quality by demonstrating that the organization is doing what it says it is doing with regard to satisfy customer needs. The ISO 9000 standard stipulates that management will be committed, involved, focused, and responsible for implementation and continued support. Facility organizational processes will be documented and periodically checked for applicability. They will be updated, made visible, traceable, consistent, and repeatable. Owners of the processes will gain authorization to make decisions, become organized, competent, knowledgeable, and responsible. ISO 9000 registration ensures that organizations understand what their processes are. The processes are documented, implemented, understood, and adhered to by everyone affected by them in the organization. The documents supporting the processes are reviewed and maintained for the purposes of providing highly detailed information to an internal or external auditing agency. ISO 9000 provides a structured approach to product quality by focusing on detailed process documentation by maintaining appropriate records. ISO Risk Register. A risk register records and manages risk within the organization. It will comprise a list of risks defined in terms of likelihood, consequences, and detectability. The risk register is a ranking mechanism that ranks risks from highest to lowest, and therefore prioritizes how, when, where, who, and why resources will be expended to address risk. The risk register aids in the development of a risk mitigation strategy. Overall, maintaining, updating, and auditing the risk register is of paramount importance in achieving corporate goals. Process improvement techniques. This subject area relates the activities of maintenance and reliability to the manufacturing or production process, to ensure that maintenance and reliability activities improve the manufacturing or production process. Apply process improvement techniques. Identify production losses, establish a process for continuous improvement process, etc. The implementation of process improvement techniques is an important cornerstone of reliability efforts. These techniques should incorporate best practices at all levels of business performance, including cost, risk, and benefit analysis. The key to establishing and sustaining improvement techniques is to involve the people who are responsible for the work, and who own, operate, and maintain the process or manufacturing equipment. This heightens the sense of continuous improvement, and nurtures a culture of empowerment, discipline, and accountability. The establishment of these techniques must align with the business plan and goals, and include sustained workforce excellence, quantitative organizational performance assessments, and ultimately, customer satisfaction. To establish comprehensive process improvement techniques, organizations have adopted various tools, ranging from International Standards Organization (ISO) standards to a Total Productive Maintenance (TPM) operational approach. A crucial step in any process improvement is to identify key performance indicators that align with the goals of the organization. The type of metrics, the process for implementing the metrics, and the quality of the metrics are just a few of the considerations that must be considered during the development stage. Good metrics are designed around the objectives of the business goals. They have three attributes. Their data is consistent, easy to understand, and quick to collect. The metrics specify accomplishments and drive continuous improvement while identifying the progress of the criteria accomplishments. Without metrics, it is difficult to measure any process. Zero defects. Ideally, one strives for zero defects in process, production, and maintenance as manifested by gains in process efficiency. A competent workforce needs to be in place to support this ideal. Sufficient training and resource allocation should be provided to support the Zero Defect Initiative, offering incentives and job satisfaction to the employees. These efforts will provide workers with the ability to consistently perform at a high level while promoting an environment of excellence. Total quality management. Total quality management is a corporate effort to project and establish an environment in which an organization continually improves its ability to deliver high-quality products and services with hopes of making itself the provider of choice to the consumer. It is a management approach to long-term success through customer satisfaction, not only by meeting customer expectations but also by exceeding them. The complete satisfaction of the customer is the focused TQM. To implement TQM, management should involve all levels of the organization, and must first clarify the corporate vision, the mission, and company values. Each employee needs to understand the direction of the organization, its vision, the organizational goals, its mission, and the operational principles, values, that will steer the focus and actions of the company. Next, identify critical success factors. Critical success factors provide the focus necessary to meet the objectives. They measure for how well the organization is meeting its objectives. An organization needs to develop metrics to monitor critical success factors. Critical success factors should be identified to measure the effectiveness of the organizational objectives. These factors help organizations monitor the progress of company-defined goals, and communicate the progress to employees. An organization needs to identify the key customer group. Knowing the demands of the customer is important to steer product and service development toward customer demand. Employees are a key customer group as well as suppliers, vendors, and volunteers. As well as, of course, the end customer. Request customer feedback to make it easy for customers to communicate positive and negative comments. There are many customer satisfaction survey tools available such as focus groups and online survey tools that can be used to determine the level of satisfaction provided. Conduct the survey on each customer group to establish a baseline of the customer's perception of current practice. This baseline is the starting point, and the point of reference to measure progress against. Develop an improvement plan. After a period, perform the same survey again on the same customer group to see if scores have improved, and if expectations have changed over time. Also, revisit critical success factors to ensure there is consistent progress being made towards goals. Root cause failure analysis. Systemic and human interaction root cause failure analysis is a method for identifying the root cause of a failure. There are several ways to conduct a root cause failure analysis. Methods include 5 whys analysis, fishbone diagram, and fault tree. The principle behind root cause failure analysis is if the root cause is accurately and completely identified and eliminated, either by re-engineering, procedural operating process modifications, or administrative controls, then that failure does not occur. Failure modes and effects analysis. Failure modes and effects analysis is sometimes referred to as failure modes and effects criticality analysis. It is an economical and methodical procedure intended to identify all possible ways a process might fail, or the failure modes of that process. The effects are the consequences of those failures. Criticality is assigned to assets within processes to denote their importance. FMEA is done to prioritize the significance of processes if the consequences of downstream failures are intolerable. If this analysis is done during the design phase, then errors can be designed out of processes, thus eliminating failures caused by that fault. Pareto principle. The Pareto principle is otherwise known as the 80-20 rule. This principle, when applied to maintenance and reliability, states that 80% of asset failures will originate from 20% of the assets in an organization. Total productive maintenance. Total productive maintenance promotes cooperation between maintenance and operations, and fosters equipment co-ownership. All operations team members learn how to perform basic care of operating equipment such as cleaning and inspections. This co-ownership encourages a vested interest in the proper maintenance of equipment, which should lead to efficient and reliable operation and processes. TPM hopes to attain no breakdowns and no accidents. It is most concerned about reducing overall operations and maintenance (O&M) costs by striving for zero process defects in a team environment. Total productive maintenance is a system of sustaining and improving the integrity of production and quality systems through the assets, processes, and employees. TPM requires full support of the entire top-to-bottom workforce. TPM requires a paradigm shift from the typical perception that maintenance is the sole owner of asset efficiency, and places that ownership across the entire facility. Proper equipment maintenance supports optimum process and operations. And proper startup and operating procedures in turn supports optimal equipment condition and minimal reactive or unplanned maintenance. This symbiotic relationship needs to be understood by engineering, operations, maintenance, environmental, purchasing, stores, accounting, safety, and human resources to be fully effective. To raise this awareness, it is imperative that every member from top management to hourly employees understands and are actively involved. Key performance indicators, KPIs. Key performance indicators are specific process variables that, when measured and controlled, allows the process to perform at a high level. It is an historical as well as a forward-looking performance measurement. All KPIs should be meaningful to an organization's shareholders, measurable by the correct personnel, and manageable by those what are measuring the data. Balanced scorecard. The balanced scorecard is a conglomeration of several KPIs used in unison to provide a complete picture of how the process is being managed. It is used to articulate a successful process strategy in actionable terms, and provides a roadmap for continual improvement. Processes. Six Sigma. Six Sigma provides a set of techniques and tools for process improvement by identifying errors early on and removing them from the process. The Sigma rating indicates its yield of defect-free products. Six Sigma equates to 3.4 product defects per 1 million production runs. Lean. When applied to manufacturing, Lean is a systematic method for identifying and eliminating waste from a manufacturing process, or muda, from the Japanese word meaning futility, uselessness. Wastefulness. Waste is found through overburden, or muri, from a Japanese word meaning unreasonableness, impossible, beyond one's power, too difficult. From unevenness in scheduled workloads, or mura, meaning unevenness, irregularity, lack of uniformity, non-uniformity, and equality. The term lean, as applied to work management, means that level loading a schedule is cost-effective. Value stream maps are used to document the steps needed for delivering a product or service. They map the steps from the start of production to delivery. These diagrams layer the process with a timeline that measures value-added activities and non-value-added activities. They will help determine which activities should be kept, and which ones should be removed from the process. 5S. 5S eliminates waste by sorting, straightening, shining it, keeping it clean, standardizing, and sustaining all that has preceded it. Some may incorporate a sixth S, and that would be safety. Making safety first is of foremost importance in everything we do. DMAIC. DMAIC stands for Define, Measure, Analyze, Improve, and Control, as applied to a known operations process. This process is a data-driven improvement process, and is a subcomponent of Six Sigma. It can, however, be implemented as a standalone quality improvement process. Change management. Change management helps to manage the effects of changes in processes and equipment. It may establish change protocol, update documentation and procedures, etc. In parallel with process improvement techniques, this subject area also relates the activities of maintenance and reliability to the manufacturing or production process of the organization. To ensure that maintenance and reliability activities improve the manufacturing or production process. The success of a maintenance and reliability program can be greatly hampered when changes made to the process, or changes to the equipment governed by the process, are not properly managed. Change can occur intentionally, such as a process modification or improvement, or unintentionally, such as component wear or general equipment degradation over time. The effects of these changes must be analyzed and managed to ensure the desired level of reliability is maintained. A formal change management process is needed to identify any significant changes to the process, equipment capability, or inventory items. A basic component of an effective change management program is the requirement that all intentional changes to the process, including temporary changes, and engineered experiments must be submitted and approved before the change can occur. After a proper application has been submitted, it is reviewed by all affected parties within the organization, including management, engineering, maintenance, safety, production, environmental, and possibly others. The review ensures that the effects of the change are properly evaluated, and that all stakeholders are properly prepared. The change management process also makes certain that all affected documents are updated, including the following: a. Drawings such as plant layouts, P&IDs, PFDs, etc. b. Maintenance documents such as MELs, PMs, FMEAs, parts lists, and others. And c. A variety of others including production control documents, safety documents, asset lists, and other documents. Upon approval of the requested change, the change can then be implemented. The management of change process must include devices to monitor the progress of the implementation. This includes making certain that documentation is created, collected, and stored in an appropriate manner. Upon completion of the change, devices must be in place to verify that the change achieved its desired effect, and that all subsequent changes to methods and documentation have been properly addressed. Concepts. Unplanned adverse effects need to be minimized, including effects on the system integrity, security, stability, or reliability, consequent to the altered or new business process. At the same time, maximize the productivity and efficiency of staff planning, coordination, and implementation of the changes. Asset management demands a high level of technical completeness, accuracy of modifications, and testing of the system before implementation. Management requires a line of sight approval of this change, and should be engaged with the process. All this is necessary for a stable production environment given the inevitable change that progress brings. Management of change. Management of change is a tool that ensures safety, health, and environmental risks are identified and controlled whenever a facility changes a plant asset layout and configuration. Documentation, personnel, and operations. MOC has inherent operational benefits. It minimizes unplanned adverse impacts on system integrity, security, stability, and reliability of the altered process. It maximizes the productivity and efficiency of staff planning, scheduling, coordinating, and implementation of proposed changes. MOC provides a stable manufacturing environment. MOC ensures the proper level of technical completeness, accuracy of modifications, and testing of systems before implementation. MOC also provides line-of-sight management approval, involvement, and responsibility. Process safety management. Process safety management, PSM, is a system of best practices to sustain safety in an environment where many hazardous chemicals are present in large quantities. PSM is a systematic analytical tool for preventing the release of these chemicals. Hazardous chemicals consist of toxic, reactive, explosive, and flammable liquids and gases. The goal of PSM is to decrease the number and severity of accidents relating to hazardous chemical releases. PSM and MOC share several attributes. Together with MOC, operational risk is managed. Manufacturing Change Request. Manufacturing Change Request, MCR, is a request originating from the manufacturing team members identifying a specific problem, and a subsequent proposed modification to the manufacturing process or equipment to rectify the deficiency. Manufacturing Change Order. Manufacturing Change Order, MCO, is a manager-approved change order describing the modifications to the manufacturing process or equipment. Processes. The processes in change management can be summarized as follows. Compile safety information on the products, equipment, materials, or processes that are changing, and write policies and procedures to use the new information. Be sure to include information on how to investigate accidents, audit compliance with safety procedures, and plan for emergency responses. Establish a way to gather employee input on the changes, such as interviews, group discussions, or surveys. Include their comments and suggestions in the draft policy and procedures. A proper MOC system requires that any changes be evaluated before implementation. The level of evaluation will depend on the magnitude of change, and how critical it is to the safety of the manufacturing process. Write instructions for all employees on every process which involved the changes. The procedures must be clear. They must include steps for performing every operation, cover safety information, state what to do in the case of an emergency, and be readily available to the employees performing the procedures. Changes being made must be thoroughly evaluated for how they affect employee safety and health. There might be a domino effect, where one change leads to more changes, and one will need to determine if the changes being considered prompt additional changes to operating procedures, or require modifications to existing maintenance procedures. Train employees on the changes. Emphasize safety and health hazards, and what to do in the case of an emergency. The training must take place before an employee can operate the equipment, or perform jobs related to the changes. Establish written procedures for what you will do the next time you have a change in safety management. Keep mock documentation, and use it as a source document to review events leading to corrective maintenance, root cause failure analysis, and process anomalies. Adhere to OSHA's documented 14 elements of process safety management, PSM. Cultivate a working relationship between engineering and the production floor. Train relevant personnel on the mock process. Nurture an environment that facilitates easy communication for the manufacturing change process, such as a change review board. Maintain processes. This subject area relates the activities of maintenance and reliability to the manufacturing or production process of the organization, to ensure that maintenance and reliability activities improve the manufacturing or production process. Maintain processes in accordance with applicable standards and regulations. Understand industry standards, understand regulatory requirements, ensure compliance, etc. Standards and specifications are used as a way of translating the efforts of the reliability program into improved performance. One approach is benchmarking, which uses a comparative analysis between internal results and the results of others, particularly if the performance of others is seen as a world-class. Gaps in performance of the reliability program must be identified, quantified, interpreted, and communicated to other functions, e.g., financial, operational, and other service departments. Action plans to close the gaps are created, reviewed, and improved on a continual basis as part of a living program approach to reliability. Measurements and action plans are posted in designated areas of the company for all employees to review. Regulations specify legal requirements that are mandatory. They include such topics as environmental effects, worker safety, product safety, and consumer or public interest. A regulation usually consists of either a federal, state, or local government technical specification or requirement. On occasion, the use of a particular private sector standard may be permitted as a means of compliance. Although regulations may seem a bit confusing and intimidating, a proper understanding of them, and how they affect a business model may actually save companies money and increase productivity. The integration of regulatory requirements with operational best practices in a continuous improvement culture is the best way to ensure that compliance is achieved, and that risk and liabilities are managed. Concepts. Operating at a world-class level signifies achieving the highest level of operational excellence among your peer group. Operational excellence in maintenance and reliability programs means your manufacturing process is poised for growth and profitability. Being world-class is being among the best, the top quartile in terms of performance, in every aspect that performance is measured. Emphasis is placed on the human side of things, and being the driver for world-class performance. Organizations operating at world-class level not only train managers but also create leaders for optimum organizational effectiveness. These organizations are viewed as model corporate citizens, while demonstrating environmental stewardship and social responsibility, and striving to achieve zero incidents. Achieving unified, success-oriented goals is the main focus. Code of Federal Regulations. The Code of Federal Regulations, Occupational Safety and Health Administration, and the U.S. Department of Labor are good resources for references on federal regulations. On the state level, consult the local Chamber of Commerce since not all states have the same level of EH&S involvement. Measurements of various types may be used, including employee engagement, training, involvement of safety committees, and injury rates. Benchmarking. Benchmarking is comparative analysis. It compares companies on a level playing field with peers within the same business group, internal processes, and performance metrics. A specific indicator such as unit cost, process cycle time, or productivity must be selected to benchmark against. Benchmarking reveals where a company's processes and performance metrics rank amongst the peer group. Benchmarking reveals the top performers in the group. Gap analysis will indicate differences in processes and procedures, and actions plans can be in place to close the gaps based on this data. Page 66 of 149. Gap analysis. Gap analysis is a method of assessing the differences in performance between current condition and want-to-be condition. Want-to-be condition should be modeled after a business entity in the same industry which is world-class by its peers. Gap analysis identifies the areas where moving from a current condition to an ideal want-to-be condition is beneficial. It improves processes, increases organizational abilities, and competencies by reducing time needed to execute corporate plans. Besides improving overall performance to the desired level, which is the ultimate goal, gap analysis also identifies by how much the need to increase performance exceeds the ability to do so. Environmental, health and safety. The goals of environmental, health, and safety are achieved through great leadership. Leaders must lead by example to drive employee engagement. An integrated systems approach such as an integrated resource plan should be used by integrating safety processes into all M&R functions and structures. This approach will result in safety becoming embedded in how a maintenance repairs and operations (MRO) unit maintains all of its manufacturing or process activities. Leading and lagging indicators monitor and drive continual improvements, while striving to achieve zero safety incidents daily. Subject matter experts, internal or external, can be selected to lead teams in a category for improvement. World-class M&R organizations extend their safety efforts beyond the workplace and into the community. SMART goals. Once it is determined that closing the gap is possible, a plan should be developed listing specific goals. These are the goals that will be achieved the target when accomplished. Specific, measurable, achievable, realistic, and timely goals methodology, also known as SMART goals, can help determine which goals to pursue. Manufacturing process reliability. Operating procedures. This subject area relates maintenance and reliability activities to the manufacturing or production process of the organization, to ensure that maintenance and reliability activities improve the manufacturing or production process. This subject requires an understanding of applicable processes, document process